Hello guys, I am Santhosh Kumar Sanka. Today I am here to present our project title Scary Run. It's an endless runner adventure. So this project is a combination of game development, creativity and programming. We developed this game using Unity game engine and C# programming language. So the main idea behind this project is to create a game that is not only entertaining but also challenging and immersive for players. So now I will explain the concept, design, development and features of our game. So comes to the design philosophy. Our design philosophy focuses on creating an engaging and meaningful gaming experience. So instead of just making a simple game, we wanted to create a story-driven environment. So yeah, give emotional experience like fear and excitement. So it combines creativity with technical skills. So we followed a simple idea. So every element in the game should have a purpose. For example, obstacles create tensions, rewards create motivation, and speed creates excitement. So overall, our goal was to design a game that keeps a player connected and interested. And coming to the objectives and game types and stories. So the main objective of our project is to design a game that improves both technical skills like coding and game development, and creative skills like storytelling and design. Coming to the game type, this is an endless runner game with action and adventure elements. So coming to the story, the game is set in a dark and mysterious world. The player is a hero who is trapped in the darkness. To survive, the player must avoid obstacles, escape enemies, move forward continuously. So as the player progresses, the difficulties increases and the new challenges appears. So the storylines makes the game more interesting and meaningful. Coming to the core mechanics, the core mechanics define how the game works. We design the game in three stages, like foundation stage, which contains the simple obstacles and easy moments, and helps the player understand the game. An escalation stage, so it differs like more obstacles appear together and requires timing and quick reactions. And mastery stage, a very fast gameplay, unpredictable obstacles, and test player skills and reflexes. So this gradually increase in difficulty ensures beginners can learn easily and advanced players stay challenged. So coming to the replayability, to make the game interesting for a long time, we add replay features like scoring system. Players earn points based on distance covered, coins collected, combo actions, and unblockables like new skins, visuals, effects, and hoverboards. So this motivates player to play again and improve. Leaderboards like player can compare scores, encourage competition, and this makes the game addictive and engaging. Coming to the technical implementations, in a briefer way, like we use modern tools and technologies to build this game, like Unity engine, which is used for game designing and development. Like it supports the graphic, physics, and animations, like smooth animations, particle effects, and physics like realistic movements and smooth control performances. Like game runs at 60 FPS, fast loading time, so works smoothly on mobile devices. So this ensures the high quality user experience. And coming to the tools and challenges, we use tools like Unity game engines and C# programming. Like coming to C#, it helped us implement a player movement, obstacle behavior, score system, challenges faced like balancing difficulty, maintaining performance, and debugging errors. So in designing engaging levels, how we solve them, like continuous testing, we tested it continuously and we optimized the code further. We worked as a team, and the team collaboration helped us a lot in this game. So this helps us to improve both our technical and problem solving skills. Like coming to the horror mode, which is a casual escape. So one of the most interesting part of our project is horror mode. So players inside a haunted castle, a ghost chases the player. Like it collect keys, avoid ghosts, and special like ghost AI becomes faster and it clears the adds tension and excitement. So like this mode combines like speed, strategy, and fear. So coming to the development pipelines, our development process had four stages, like concept phase idea, which plans the game design, and asset creation characters, which helps for environmental design, and which implements coding features, adding physics, and polishing bug fixing, improving graphics, and testing so on. So this structured approach helps us to complete the project efficiently. Coming to the outcomes and a future scope, which we can add in further moment, like for this project, Unity 3D development to add on like multiplayer mode, better graphics, levels, expanded storylines, and we aim to improve the game further and make it more advanced. So coming to the conclusion, in a briefer way, Unity programming and teamwork. It helps us understand real world game development and improves our skills. So yeah, from now my teammate will explain the further details.
Hello everyone, I am Gayathri Budati. Now I will explain the game concept and gameplay of our project Scary-Run. And Scary-Run is based on the endless runner concept, where the game does not have a fixed ending. Instead of the player continues playing as long as they can survive. In our game, the player controls a cube character that automatically moves forward. The environment keeps generating continuously. The main goal of Scary Run is to survive as long as possible and achieve a high score. And this type of concept is widely used because it creates addiction and replay value and encouraging players to keep trying again. And the gameplay mechanics are the cube moves forward automatically without stopping. Obstacles are generating randomly in the game, and then the player must jump and doodle obstacles at the right time. And if the cube collides with another obstacle, game over. And the futures of the endless game are infinite gameplay and dynamic obstacle generation and increasing difficulty and simple controls and control tracking system and finally high replay value. This is no final level. The game continues endlessly until the player fails. And the conclusion overall, the main idea of our game is to test the player's reflex and timing and concentration, where providing a simple yet addiction gaming experience. Thank you.
Hello everyone, I am Madasi Sathwik. Thanks Gayathri. Now let's talk about the game environment we have created in Unity. We built everything inside Unity 2022.3 LTS. So the scene contains a long 3D ground platform made of repeating tiles, so it looks infinite. The player cube with a bright material, so it stands outside. So, and we have created another scene like multiple obstacle prefers, skippy clubs, walls, and moving barriers, and a careful position main camera that follows the player smoothly. So, in the scene view, we have designed the initial layout. In the game view, you exactly see what the player sees. That means the inspector window was used to tweak every property and mass and drag and collide size and everything. So the hierarchy panel helped us keep all objects organized. So the player obstacle spanner, ground tiles, UI and canvas etc. was designed, and we also added directional lighting with soft shadows for better visibility. So rigid bodies components on the player for realistic physics. Colliders on every obstacle and the ground, a simple particle system for gem, dust, and collision sparks to make it visible satisfy. So one important decision was making the ground use a moving texture trick instead of actual moving the entire world. This keeps performance high even after 10 minutes of play. So the clean and optimized setup gave us a smooth interactive environment that runs at 60 FPS on the normal laptops and the Android mobile phones. I will hand over to Vivek, who will dive into the actual C-sharp code that make the cube move and jump.
Hello everyone, I am Anumalla Vivek Sai. Let me explain the code behind player movement and control. The cube moves forward automatically. Here the core line we use the player control speed. Attach the cube. We also increase speed over time for significantly. For jumping we trigger the spacebar press. We need a small ground check using a raycast so the player cannot double jump in the air. We also include left-right line movement with arrow keys using transfer position, vector left, land distance for smooth side step. All of this were in clean state machine so the code remain reliable and seeing the control fields. Extremely exactly what we wanted for a endless runner. That the movement system now Srinath will we explain we handle collision and overall game logic.
Hello everyone, I am Limgampelly. Now I will explain the collision detection and game logic. Every optal has a player has a box collider on the player we attached a script that uses Unity built-in method. When a collision happens, we immediately call the game manager to stop all movement, freeze the Ergis body, show the game over UI with your final score, and offer a restart button that reloads the scenes with for the scoring, we use a simple timer in the game manager. We also added a sound effect and screen shake on collision to make the game over moment feel impactful. The center logic insecures the game reacts instantly to player actions. To provide clear feedback, everything is modular so we could easily add power-ups later. Now I will pass it to our next player.
Hello everyone, I am Asmaja. Now I will explain the challenges we faced and interesting parts. Challenges. Player movement was not smooth. Collision detection issues. Difficulty balancing. Camera tracking problems. Solutions. Adjust physics settings. Fixed collider alignment. Optimized speed and optical swapping. Use smooth camera, follow script. Most interesting part. The most exciting part was seeing the cube move in real time, implementing jump mechanics, testing the game as a team.
So in this game, the core concept is very simple but highly engaging. Scary Run is an endless runner game where the player controls a block, a cube, that continuously moves forward without stopping. The movement is automatic, so the player doesn't need to control forward motion. Instead, the entire focus is on reacting quickly and avoiding obstacles. The block keeps sliding forward on its own, creating a fast-paced gameplay experience. As a player, your job is to control the block's movement sideways or make it jumps, depending on the controls, in order to escape from obstacles that appear in its path. So the obstacles are generated continuously as the game progresses. This means the player never knows exactly what is coming next. So which makes the game more exciting and unpredictable. As time goes on, the speed of the block gradually increases and the obstacles may appear more frequently, making the game more challenging. So now coming to the main gameplay mechanic survival, the goal of the player is to survive as long as possible. So you need to keep dodging obstacles with proper timing and quick reactions. Even a small mistake can end the game. So whenever the block touches or collides with an obstacle, the game immediately stops. The collision detection is an important part of the game logic. So as it determines when the game is over, at the same time, the scoring system works continuously in the background. So the score increases as long as the player is alive and moving forward. So the longer you survive, the higher your score will be. So once the block hits an obstacle, the game ends. And the final score is displayed. So this score represents how long the player managed to survive in the game. So overall, the game is designed to test the player's reflex, timing, and concentration. So even though the mechanics are simple, the increasing speed and continuous obstacles make it challenging and addictive.
In our game Scary Run, the overall functionality is achieved by combining backend logic and game assets and important game development concepts. The backend mainly consists of the Unity game engine and C# code, and automatic player movement and obstacle spanning system and collision detection game over, and then score tracking system. And then coming to assets, they are the visual and audio elements used in the game. We use it simple assets like the cube for the player and blocks as obstacles and basic environment, including ground and background. Perhaps are used to reuse objects efficiently, especially for obstacles. Lightning and basic efforts are added to improve the visual experience, and player is equals to cube and reusable objects. And coming to the important terms, understanding key terms like game objects and physical scripts and scoring systems help in building the game effectively. Physics is used to apply gravity and realistic jumping, while the score system tracks how long the player survives. By combining all these elements, we were able to create a smooth, interactive, and engaging endless runner game. Thank you.
Let me explain the technical stack used in Scary Run. So first, we use the Unity game engine as our primary development platform. Unity provides a powerful environment for building 2D and 3D games, along with building support for physics, rendering, and scene management. It allows us to quickly design the game world, place objects, and test gameplay in real time. So for scripting, we used C Sharp, which is the main programming language supported by Unity. All the game logic, including player movement, obstacle spamming, collision detection, and scoring, is controlled through C Sharp script. So let me explain the player movement system. So the play in our game, the cube movement moves forward continuously. To achieve this, we wrote a C Sharp script that updates the position of the player objects every frame using Unity update function. In this function, we used a movement vector to move the cube forward along the z-axis at constant speed. This creates the endless running effect. Additionally, implemented player or input dot movement system. Let's start with player movement system, which is one of the core mechanics of the game. In our game, the cube moves forward continuously. To achieve this, we wrote a C# script that updates the position of the player object every frame using Unity update function. In this function, we use a movement vector to move the cube forward along the z-axis at a constant speed. This creates the endless running effect. Additionally, we implemented player controls using keyboard input by using input.getKey or input.getKeyDown. We detect when the player press keys to move left, right, or jump. Based on the input, we adjusted the cube position accordingly. This combination of atomic forward motion and manual controls gives the player a smooth and responsive gameplay experience. Now let me explain the obstacle generation system. So next we design the obstacle spamming system. Instead of placing a obstacles manually, we use a dynamic spamming approach. This means obstacles are generated during runtime using a C# script. We create a preferred for obstacles and use a script to the prefabs at regular intervals. This was done using functions like insisting with timers or co-routers. We also randomized the position of obstacles to make the game less predictable. This ensures that every gameplay section feels different and challenging. Now let me explain the collision detection. Another important part of our game is collision detection. Unity provides built-in physics and collision system using colliders. We attach collider components on both the player cube and the obstacle. In our C# script, we use the on collision enter or trigger enter method to detect when the cube hits an obstacle. When a collision is detected, the game immediately stops. We game using timescale equals to 0. So this creates a clear game over condition where the player fails to avoid an obstacle. Now let's talk about the scoring system. So the scoring system in our game increase continuously as long as the player survives. We implemented this using a simple timer based logic in a C# script. In the update function, we increment the score based on time, usually by adding time delta time to a score variable. So this ensures that the score increases smoothly over time. We then display the score on the using Unity UI system such as text or text mesh pro components. Once the game ends due to a collision, the score stops updating and the final score is shown on the player. Okay, thank you all for watching. Our team members are Santhosh Kumar Sanka, Budati Gayathri, Madasi Sathwik, Anumalla Vivek Sai, Limgampelly Srinath, and Enaganti Asmaja. We sincerely express our heartfelt gratitude to our mentor, Dr. Chandra Jadala, for his constant guidance and valuable insights and continuous support throughout the development of this project. His mentorship played a crucial role in shaping our ideas and helping us successfully bring Scary Run to life. If you enjoy Scary Run, Please like, comment, and subscribe. We will drop this full code and Unity project link in the description. See you in the next project video. Thank you.